Welcome Math 20-1s to lesson number 7, the final lesson in your workbook, Linear and Quadratic Systems and Inequalities, lesson number 1, solving quadratic inequalities in one variable by sign analysis. Last lesson we did this by case analysis. Essentially what we're doing today is another way of solving these types of problems. So you can essentially just take whichever way you find easier or more intuitive, and you can work that way. So we can use sign analysis either by using test intervals or by using a sign chart, and we'll get into that. So let's start with solving quadratic inequalities in one variable using test intervals. So part 1, it says the graph of a quadratic function with the equation y equals x squared plus 2x minus 8 is shown below. The zeros of the function at -4 and +2 can be used to divide the x-axis into 3 different intervals. These intervals can be seen by this first part where x is less than -4, second interval when x is between -4 and +2, and then when x is greater than 2. So these are our 3 intervals. So on the interval where x is less than -4, is the function positive or negative? Well, in this case, obviously, our function is positive. On the interval between -4 and 2, is our function positive or negative? Well, this interval is negative. And on the interval where x is greater than 2, the function, again, is positive. Well, what does this mean and why does this help us? This is going to help us down here to determine our solution to the inequality when our inequality here is greater than 0 and when it's less than 0. That's ultimately what we're going to determine. Remember, greater than 0 is positive, less than 0 is negative. Before we get there, let's stop and fill in this chart. Essentially, all we're doing is we're rewriting what we had up here. So on the interval, when x is less than -4, the sign of x squared plus 2x minus 8, remember that's our function, the sign of this is going to be positive. You see it's positive here. And so the sign of x squared plus 2x minus 8, if I put x into the equation, when x is less than -4, I'm going to have a positive value. However, when x is between -4 and 2, i.e. if I put x into my little equation here, and if the value I put in is between -4 and +2, any one of these, I'm going to have an output value that is negative. And I know that because my graph comes now below the x-axis, which represents negative values of y. But when x comes out on the right-hand side and is greater than 2, my sign changes again to positive values. That again means when I insert values into this equation where x is greater than 2, I'm going to have a positive value of y. So now let's go ahead and complete the following. What is the solution to our inequality when it's greater than 0? Well, we said our inequality is greater than 0 when x is less than -4 and when x is greater than 2. And when is the solution to the inequality of x squared plus 2x minus 8 less than 0? Well, it's less than 0 when it's negative, and so that is in the interval between -4 and +2. And we can write that as such. So solving by sign analysis using test intervals, we say that the intervals determined by the zeros of the function, you might want to underline that, we determine our intervals by the zeros. So in solving a quadratic inequality without graphing, we use a value of x in each of these test intervals to determine whether the quadratic function is positive or negative, as shown in the example below. So what we're going to do is we're going to take our inequality and we are going to represent it as an equality. And then we're going to find the roots of the equation, and we're going to form our intervals from there. After we get our intervals, we're going to actually do test numbers in each interval to determine whether the output value is positive or negative, and that will determine our inequality. because we want to know when this is less than 0. So let's go ahead and do that. Again, just to reiterate, this inequality is less than 0. That's when we have output values that are negative. So part A says, write the inequality in factored form and determine the roots of the equation. Well, to write it in factored form, I'm going to start by simply writing it. Now, to factor this, I want two numbers that will multiply to positive 14 and add to negative 9. It would be negative 7 and negative 2. Well, they now want us to determine the roots of our equation. So let's go ahead and do the roots of this equation. So I'll start by writing my equation. We'll factor it in the same way that we did previously. And now we'll solve for my x value. I get that when x is equal to 7 and when x is equal to 2, my function will equal 0. So these are going to be our intervals. We said the intervals are determined by the zeros of the function. So I have three intervals that are formed from this. Perhaps I should rearrange these in order with in ascending order with the lower number first. Our first interval is going to be the area of the graph where x is less than the first number. So that area would be where x is less than 2. It might help to have a visual. Here I've put 2 points on our graph. We could say this is at 2 and this is at 7. So my first interval is the part of the graph to the left of 2. My second interval is going to be the distance or the part of the graph between 2 and 7. So that's represented as follows. X is greater than 2 and less than 7. And then the last interval will be the section greater than 7. So now that I've done this, I want to determine the sign of my function, whether or not it's positive or negative for each of these three intervals. Remember, this is exactly what we did the page before. We had three intervals, and we determined the sign of the graph. So last time we did it by looking at the graph, and if you have your function and you're not sure, you can go ahead and graph it. That is one way of doing it, and you can look at the graph. Another way of doing it is by simply testing certain values and putting them into your formula to see if you get positive or negative solutions. So let's pick some number less than 2. I don't know, I'm going to pick 0 because I think that will be easy to enter on my graph, or sorry, for my equation. So if I have x equal to 0, what is x squared minus 9x plus 14 going to equal? Remember, that's my equation. If we were to graph this, we would have y equals. Well, we simply input 0 into our equation for x. So we get 0 squared minus 9 times 0 plus 14. Well, this is obviously just equal to 14. And 14 is positive. So we'll write that we have positive values in the interval where x is less than 2. And if we want to look at this graphically, we'd have some sort of positive value here. Well, what about the interval between 2 and 7? We can pick any number between or in that interval, just don't pick the numbers on the ends. So I could pick 3, 4, 5, or 6. I'm going to pick 5. So I'm going to substitute that into my equation, and I get 5 squared minus 9 times 5 plus 14. And this is equal to negative 6. So when x is 5, y is negative 6. So we're going to write this is negative up top here. So I put that into my chart. What that also means is that on the interval between 2 and 7, I have negative values. Well, what about the interval where x is greater than 7? I can pick any number. I'm going to pick 10 because we all know how to multiply by 10. Again, I can pick any number greater than 7. Enter 10 into my equation. I get a value of 24. So when x is 10, my y component is 24. This is obviously greater than 0. It's positive. So I can enter that into my chart up here. So all this work we did in order to determine the solution for our inequality. So when is our inequality less than 0? Well, it's less than 0 when it's negative, so that is on this interval between 2 and 7. Let's now go on to letter D. It says use the table to state the solution to the following inequality. Well, when is x squared minus 9x plus 14 greater than 0? Well, it's greater than 0 when it's positive. So we know our function is positive when x is less than 2 and when x is greater than 7. So we'll write that down. What about for part 2? When is this less than or equal to 0? Well, what we can do for the less than or equal case is we just add in less than or equal signs to this original. Notice the only difference here between D and E part 2 is that we have this less than or equal sign. Again, to explain it another way, because I know my function is equal to 0 at 2 and at 7, that's what we determined above. Our zeros occur at 2 and 7, and we can see that from our function. It equals 0 at 2 and 7. So when is the graph less than or equal to 7? Well, I actually need to include the points 2 and 7 in that interval now. And so I can do that by saying less than or equal, or greater than equal, or sorry, yes, x is less than or equal to 2, and sorry, I had this right the first time. X is greater or equal to 2 and less than or equal to 7. Last but not least, when is this greater or equal to 0? Well, we have the same case as here in I, except we now have the greater than or equal to, so we're going to add those in to include the points of 2 and 7, because now we can have those points when our function is equal to 0. Just to repeat, our function is less than or equal, when our function is greater than or equal to 0 when x is less than or equal to 2. We saw that up here. Likewise, our function is greater than or equal to 0 when x is greater than or equal to 7. So that concludes our bit on using, oh no, I lied, we have one more example. So it says the values we use to determine whether a quadratic expression is positive or negative are called test points. So these are our test points, the values that we use actually. So in this case, our test points are 0, 5, and 10 along the intervals that we just determined. So let's go ahead and do one more, solving the inequality, class example number 1, using test intervals. I'm actually not sure why they really wanted us to go ahead last time and determine the zeros of the equation, because we can determine the zeros simply from the inequality. That is, when our inequality is equal to 0, we can. So let's go ahead and do that. We'll start by factoring out an x. So factored out an x, we can see now that we have two solutions. Two intervals. 2 points are going to form our interval. One where x is 0, because this would normally be a 0 if we actually had an equation here, and the other is where x is equal to 8. Let's go ahead and write in our intervals. Well, our first is when x is less than 0. Our second is when x is between 0 and 8. And our last is when x is greater than 0. Sorry, when x is greater than 8. Again, how did I determine the interval? Well, if I was actually solving this as an equality, I would have two solutions where this is equal to 0. One where x is equal to 0, and one where x is equal to 8. So these two numbers, the zeros, form my inequality. The smaller one I put first, where x is less than that value. My second interval is the range between the two, and my third is when x is greater than the second number, that is the larger number. So now I'm just going to use test points to determine the values, whether the sign is positive or negative in these three intervals. So let's pick a number when x is less than 0. I'm just going to pick -1. Evaluate this interval, I'll get -8 minus 1. That will be -9. As -9 is negative, I'm going to write that in this interval. What about when x is between 0 and 8? Let's pick a number between that. I'm going to pick 1 because I think that will make it easier to evaluate. And we see this is equal to 7, so that is positive. What about when x is greater than 8? I'm going to pick 10 again because that's an easy number to solve. Well, then I'd have 8 times 10 minus 10 squared, so that would be 80 minus 100, which would be equal to negative 20. So that's negative then when x is greater than 8. So we're almost done. The last thing we need to do is actually answer the question. It says, it asks us to solve the inequality 8x minus x squared when that is less than or equal to 0. So when is this less than or equal to 0? Well, when it's negative. So when x is less than or equal to 0, and when x is greater than or equal to 8. Remember to make sure you have greater or less than or equal to and greater than or equal to, because that's what the question has. I could have even, during these intervals, I likely could have even put those in here. The only problem is, maybe I can explain that right away. The reason we don't actually put less than or equal to in this section is because if we put or equal to, then I actually could include the test case of x being equal to 0. And that would not be negative or positive, that would be 0. So even in these intervals, we still have less than or greater than. But to answer what they're really asking for, we need to include that in our final solution. Again, just to reiterate what this means, if we want to look at this graphically, I have my 2 points for my test intervals 0 and 8. Well, what this means is that when x is less than 0, I have some negative value. When it's between 0 and 8, it's positive, and when it's greater than 8, it becomes negative again. That's all we're doing. We're doing this simply without actually needing to draw the graph. Okay? One thing I should tell you is that there is perhaps even an easier way of doing this. We can manually input these values, and that's fine. But another way we could actually do this is by using our table of values on our graphing calculator. Now, I don't want to throw too much information at you, but I think it might be helpful just to speed your process up and perhaps just reinforce what we've been doing. I've entered in 8x minus x squared into the y1 portion of my graphing calculator. Graph this, I will see that this is exactly what I saw. Okay, I've already shown us the graph. We can also graph it to confirm. Our interval that is less than or equal to 0 is when x is less than or equal to 0 or greater than or equal to 8, which is what we solved. So we could have actually just typed this into our graphing calculator and determined the solution. However, this is teaching us how to do it without our graphing calculator. We know that our solutions are correct because what we did is we just picked -1, and then we determined, okay, that's negative, so I know that the part of the graph is negative here. I picked a value in here, I think it was 5, and we determined, yep, it's positive. We determined -10, yep, it's negative. But another way, actually, of even determining these points is if I just go to my table of values, and I do that by pushing second function and then graph, we can see on my table of values where the values are positive and when they're negative. So I wouldn't actually need to input my values. I can just look at this and see when does the graph become negative? Well, it becomes negative when x is less than 0. I can see that here. When x is less than 0, my values become negative. When does it change to positive? When does it change to positive? It changes to positive at 0. Or at 0, not quite, but at 1 for sure in that interval. And then it changes again to negative when x is greater than 8. So in other words, this table of values can do all the work that we just did manually, although it might still be easier to just look at your graph. I hope you found that somewhat helpful. We're now going to finish this lesson by solving quadratic inequalities in one variable using a sign chart. So at the beginning of this lesson, that is in part 1c, Colin solved the inequality as given. and as given, using test intervals. So he used test intervals. That was this problem right here. This was Colin. Was this Colin? And the very first one was Colin here. I don't remember seeing a name Colin, but apparently it was Colin. It wasn't us. So his elder brother, who had just completed high school, showed him a different method which was useful in solving more complicated inequalities. So he did this using a sign chart. First step was to factor the quadratic expression, so that's done here. We factored it into x plus 4 and x minus 2. We determine the zeros. Well, our zeros are at negative 4 and at positive 2. And now we use a sign chart which shows the sign of each factor. It shows the sign to the left and to the right of each of the zeros. So again, now we're simply just looking at each factor. So we write our factors on the left-hand side. We put x plus 4, our first factor here. We put x minus 2. We write that down over here. And then we're going to determine the sign of each of these when x is less than negative 4. Well, when x is less than negative 4, x plus 4, if x is less than negative 4, is still going to be negative. Likewise, x minus 2, if x is less than 4, or negative 4, is going to be negative. So our product, we're going to say, is positive. We have our intervals now to talk about. When x is negative 4, we know that x plus 4 is equal to 0, hence it's our 0. When x is negative 4, x minus 2 is still going to be negative. So we have 0 and negative. We're going to write 0 under the product. Next, when x is between negative 4 and 2, well, x plus 4 is going to be positive over that interval. However, x minus 2 is still negative over that interval. But when we get to 2 here, we see that suddenly, x plus 4 is still positive, but x minus 2 is going to be equal to 0, so that leads us to this final step, where both x plus 4 and x minus 2 are greater than 0. That occurs when x is greater than 0. Then both of these can be positive. Both x plus 4 obviously is going to be positive, but now x minus 2, because x is actually greater than 2, will actually still be positive. So this chart has actually given us the answer. So the 2 points where our product is positive, notice that that's what we wanted. We wanted to know when x squared plus 2x minus 8 was greater than 0, i.e. positive. The 2 points where the product is positive gives me my solution. So I can write x is less than negative 4, or x is greater than 2. Also stop and take a notice on how similar this is actually to case analysis. In case analysis, we looked at this and we said, well, if both x plus 4 and x minus 2 are positive, then I will have a solution. And if both x plus 4 and x minus 2, if both of these were negative, i.e. positive, positive, negative, negative, both of those provided solutions where the product of these two terms was greater than 0. And notice that's exactly what we have here. We have 2 negatives making a positive product and 2 positives making a positive product. So this chart here is in some ways an application of case analysis. This is more or less just another way of doing it. So again, the solution is where x is less than negative 4 and x is greater than 2. So let's stop and take note. Although this method may appear complex at first, it is actually easier to use when solving more complex polynomial inequalities and rational inequalities in higher level math courses. So this might be a good skill to be able to use, especially when we talk about later. If you're planning on doing calculus, you will need to be able to use this method. So class example number 2 says, use the above chart to state the solution to the inequality x squared plus 2x minus 8 is less than 0. Well, we just did for when it's greater than 0, so when is it less than 0? It's less than 0 in this interval here. It's negative. When x is between negative 4 and positive 2. So this is my solution again. I just did that now by looking at the chart. Let's go ahead and do one more of these. Class example number 3, letter A says factor fully the expression that they've given us, and now we're second part is we will actually solve this inequality. So they've kind of broken this down into two parts for us. Let's go ahead and factor this. I'm going to start by noticing that I have a common factor of 3. And actually I want a positive x squared, so I'm going to factor out a negative 3. So now what I'm going to do is I'm going to multiply 2 by 6. So essentially I want to factor this term on the right, so I'm going to multiply 2 by 6, which is equal to 12, and I want to piece this 13 apart into two parts, which will include 12. Well, I can write 13 as 12 plus 1x. So now I'm going to factor this 2x squared plus x. So I factored out my x from the, or 2x from the first term. I now have a common factor of x plus 6, and so I'm going to factor that through. And I'm left with negative 3 times 2x plus 1 times x plus 6. Again, how did I get this from the above step? I have a common factor here, the x plus 6, so I take my common factor out, I multiply it by what's left here, 2x plus 1. I have 2x plus 1 here and x plus 6. So now we're going to use this information to solve the inequality of this same expression when this is less than or equal to 0. I'm going to write each of my terms here to this chart. I've zoomed it in because I think I've built my chart too small. I'm now going to create my intervals up top here. Well, in order to create my intervals, I actually need to solve for each of these. Solve, I get two values. I get x equal to negative 6 and x equal to 1/2. I'm going to start by putting my negative 6 over on the left. Remember that's because it's smaller. So I have my negative 6 here. I have my area where x is less than negative 6. I now have my interval between negative 6 and 1/2. My apologies, I made a mistake here. I forgot a sign. I have my intervals when x is less than negative 6, when x is negative 6, when x is between negative 6 and negative 1/2, and when x is greater than negative 1/2. Well, why did we even bother bringing this 3 down? Because when we go to substitute values in of x, it doesn't matter. Well, I'm just going to know that negative 3 is always going to be negative 3 throughout this whole case. But we will see later why it's important to include this negative 3. So now we ask, is x plus 6 positive or negative in the interval where x is less than negative 6? Well, this is going to be negative. When x is equal to negative 6, I get 0 here. When it's between negative 6 and negative 1/2, this will be positive. This will still be positive, and this will still be positive. However, for 2x plus 1, it's going to be negative all the way until it hits negative 1/2, and then it'll be equal to 0, and after that it will be equal to positive. So what does my product look like then? Well, my product is going to be the sum of all these signs. Again, this is because this is my final term in factored form. When I have each of these expressions, when x is less than negative 6, I'm going to have a negative value here, I'm going to have a negative value here, and I'm going to have multiplied by negative 3. So in total, that is going to give me a negative product. When x is negative 6, I'm going to have 0 because it doesn't matter what the other values are. If I multiply it by 0, it's going to come out as 0. This next interval is going to come out as positive because I have two negatives and a positive. That will make a total sum of positive. This next one will be not negative, sorry, this will be 0 because we have a 0 here. And the last section will be negative. Again, just to reiterate what this means, is we took each of these terms, and this chart determines all the cases for us. So that we have, it essentially tells us what the product is going to be of our function. And if you went to graph this, you would again see that this is the case. When x is less than negative 6, I have a negative value. When it's between 6 and negative 6 and negative 2, it's going to be positive. When it's greater than negative 1/2, it's going to be negative. So now that we have our product, we can easily solve our inequality. So when is this less than or equal to 0? Well, when x is less than or equal to negative 6, and when x is greater than or equal to negative 1/2. That's when we get a negative value. So that's when it's less than or equal to 0. And just to reiterate what we did in this lesson, if you already know how to solve these inequalities, by all means go ahead and use your graphing calculator, unless I specifically ask you not to, and to use it during by one of these cases. But essentially what we have here is more options of solving inequalities. So we have our test interval, where we choose certain points according to our interval, and then we have our sign analysis method that we just finished up. In all cases, we're simply wanting to know which values of x will satisfy our inequality. For instance, which values of x will give us an expression so that x squared plus 2x minus 8, for instance, when that's greater or less than 0. That concludes lesson number 7, which also, fortunately, concludes our workbook. So congratulations, nice work.